welcome back to Exploring Northern Ontario. Today we're in my garage and we're looking at the samples that I've collected over the summer. And today's focus will be on a particular sample, and that is chalcopyrite. Why I chose chalcopyrite? Well, it's one of the many sulfides that I've collected this summer. So today we're going to be roasting these sulfides to release the SO2 or sulfur dioxide gas. I often wondered, what could we do with that gas? So we're going to try like some of the big refineries do, or the big smelters I should say. Many of the big smelters have been taking a lot of heat for the last few decades for releasing so much SO2 into the atmosphere. So what they've learned to do is they've learned to capture the SO2 and create sulfuric acid. I will try to do a small experiment where I capture the SO2 or sulfur dioxide and convert it into H2SO4 or sulfuric acid. Alright, so the first thing that I have to do, of course, is crush down my chalcopyrite. I have a small, I think it's called a rock collider. It's not really a crusher. The rocks, the rocks smash into each other in here and it breaks it up really nice. Next, I'll take that crushed chalcopyrite and filter it. Perfect. Nice and fine. See that shine? Those are the sulfides. Alright, so next we have to feed our sulfides into this little dish that I've specially set up for our experiment. So, let me explain how this is going to work. Obviously, this is where we're going to roast our sulfides. So we just have a simple little propane torch. It heats it up and this will glow red. The sulfides will begin to roast. The gases will travel up this aluminum pipe and into this beaker, which is turned upside down. This is going to be our mixing chamber. Okay, so SO2 gas coming up into the beaker. Now, we also need our source of water. So we're going to boil some water in this flask. The water will turn to steam, go up this pipe, and also into the mixing chamber, our beaker. There, the steam will mix with the SO2 gas and form H2SO4 or sulfuric acid. It'll start to condense on the glass, drip down and into a container, which I will put right here. While we're waiting for this to heat up, I just wanted to mention that this experiment or this process has been happening every day all around the world for years. As sulfur dioxide gas rises into the atmosphere, mixes with the clouds, and falls back to Earth as acid rain. Everyone's heard of acid rain. Well, that's what we're trying to duplicate right here. Is in this mixing chamber, our SO2 is going to mix with the steam, which is our clouds, and then drip down the side of our beaker in the form of acid rain. I had to wait for my water to start boiling, which it is boiling very well now, and I've got plenty of steam going up into the beaker. Now, that steam is going to condense on the glass of the beaker and start to drip down, and I have to see where the collection points are going to be. Once I know where the water is starting to drip and I can collect it, then I'll light the torch here and start roasting to send my SO2 gas up to mix with the steam. But first, I want to know, where's the water going to start dripping? Because I need to collect our sulfuric acid. Okay. So our water has started to condense on the beaker and it is dripping. You see all of it dripping down, and we're collecting it in this container right here. We're also collecting some of it in this container because it's dripping in many different places. Okay, so let's light our torch. Start roasting our chalcopyrite. Soon that's going to turn red hot, and before long we'll be sending our sulfur dioxide up this pipe to mix with our steam. All right, that didn't take very long. Already you can see the smoke, sulfur dioxide gas. So it's going to be mixing now in our mixing chamber with the steam, and any water running down the side of this glass now is going to be in the form of H2SO4 or sulfuric acid. It's really dripping in there now. So we're starting out with SO2. We're adding our H2O to give it its extra hydrogen and oxygen molecules, and now we're producing H2SO4. And we're going to confirm about that sulfuric acid when we do a litmus paper test, and we'll test its pH, and that'll let us know that we're adding acid into our water, or acidity into our water, I should say. Okay, I noticed one problem is that with all that superheated gas, the SO2 going up, it's making the glass too hot. So condensation is very slow. So I'm going to turn on a fan, and I'm going to blow air directly on the outside of the beaker, cooling it down, hopefully producing more condensation and thus more acid. Let's see if that makes any difference. Okay, so the fan has really seemed to increase the amount of condensation on the outside of the beaker. So getting quite a few more drips now. And I can tell you for sure we're producing SO2 because I'm starting to get a little bit of that acid throat, because the SO2 is mixing in my throat and in my lungs, and it's creating a small amount of sulfuric acid. I should be wearing a respirator, but this isn't the first time I've inhaled SO2 gas. I used to work at the Inco smelter, and there you're required to wear a respirator all the time, but sometimes you have it off, the air is good, and then suddenly they have what they call a downdraft. And all the gases that are heading up the superstack start coming down. And then the whole place is blue and you can't even see. And you take one breath of that, and believe me, that's about 1,000,000 times worse than this. Of course, this isn't good for you. I'm not going to do this every day. I do this one time. And of course, if you're going to do it, I recommend you do wear a respirator. Just to make sure, I put a little bit extra of the crushed sulfides in there, just to make sure we're producing enough gases. Mix that around a little bit. Our steam, there's no shortage of steam. And the SO2, I can smell it. Very hard to see, but I'm smelling it. And we're still collecting quite a bit. One thing that I forgot to mention for our setup here today is we have a hose that's been cut. A little tube, we cut it so it would fit on the lip of the beaker, and then it would collect all the condensation that comes down the beaker into the pipe. And because our beaker is on an angle, it leans all down into the pipe and then drips out. It's not the best setup in the world, but for our purposes, it'll work just fine. Let's take a look at our sulfides after about half an hour of roasting them to remove the SO2. You can see, if we look in the light, they've turned red on us. They've oxidized. Just like when you roast it. So where did all that sulfur go? It went into the steam and the water that condensed on our beaker. This is what we ended up with. It's not a whole lot, but it's enough. We're going to test it now. So I just have some standard pH paper. So we'll take one of our litmus paper, dip it in there for a few seconds. There we are. And what have we achieved? Put it there. It's closer to a 1 or a 2. In this light, it looks like it's closer to a 1. Sulfuric acid is usually a pH between 1 and 2, depending on its concentration. Let's take a look out in the sunlight. Did we achieve 1 or 2? Hard to say. Maybe we have 1.5, I would guess. pH of about 1.5. So, our experiment was a success. We've created mild sulfuric acid. Litmus paper tells us the story. Now we've got a pH of between 1 and 2. Sometimes it looks a lot like 1, sometimes it looks more like 2. Let's call it 1.5. One more thing I'd like to do before I end this experiment is to try to increase the concentration of the sulfuric acid. How we're going to do that? Well, we're going to boil off some of it in this beaker. We'll boil off about half of it, and then we'll test it again with the pH paper and see if we've increased the concentration or not. Okay. There's not much left. I've reduced it to just that small amount. And let's test this and see if we increased its concentration at all. So remember the last one we had. Let's put it up against it and see if it's any darker. Perhaps it's a little bit darker. I think we've made it a little bit darker. I think we've increased the pH perhaps another half a point. That's good enough for me. I'd call that experiment a success. So we've crushed down our ore, we've roasted it, we've taken the SO2 gas, converted it into H2SO4 sulfuric acid. Thanks for watching.